Here we go, looking at 7.2. We're looking at similarities. We're looking at similar ratios. We do have a new character. So this is kind of like the little thing that is above an equal sign that makes it congruent. This is saying that these figures are indeed similar. All right, and so when we have or if we're just looking at the letters that make up a shape, like this would be making up a four-sided figure, we can just look at the order of these things. So if we're looking at similarity, L is the third one, therefore the third letter in the next figure would be the corresponding part that is similar. Here we can also look at more than one part of it. So we're looking at a side. So C to H is to Y to X. So we read this as such. So we're saying that there is something going on between these two, and this is equal to the same similarity. So we're looking at, well, what order Z to Y comes. So if we look over here, Z to Y, we're going from last to first, and we should do the same in the other figure, which is V to C. That's what happens here. And just make sure when you're plugging these in, you have to use capital letters. In this next one, we're doing the same thing, except we have a figure to look at. So we can look at it in terms of just the order of the letters, so E and N, or we can look at it on the shape itself, and we do that corresponding here. And then we're looking at sides. So N to O, we're going from here to here, so that would be E to F, or we can just also look at the order, which is done, N and O, E to F. So either way, whichever works best for you in order to write those out. Here we're looking at ratios and deciding whether or not the figure is similar. As you can see, these aren't congruent because they're not the same size, right? That's what congruency says. But similar says that we have some type of ratio, a number that I can multiply by one side or each side. And so it has to be similar for all sides. So we try and find what is that ratio? What is that factor or scale factor? And so I take the corresponding side. So we look at this hypotenuse here, so 20 and 5. So if we divide those, I get 4. We have to look at it in that way because it says ABC, the larger one to the smaller one. If it was reversed, then we would definitely reverse this and we would have 5 divided by 20 and get 1/4. So it can go either way. So we have to pay attention to which one is referring to and do the same. Since we get 4 for all of the corresponding sides, then we can say that these are indeed similar, and that is by a factor of 4. So don't write it as 4 to 1, reduce it and write it as 4. Here we're going to do that same process here. So I'm looking at corresponding sides. So I have 35 over 25, which is 7/5. And then I have 16 over 12, which is 4/3. So no, this is not similar because the sides are not proportional. And here we're going to apply those and we're going to create some equal proportions to figure out a missing variable. And so we're looking at the smaller triangle on top that has sides y, 13, and x, and the larger triangle, which has sides 10, 26, and 24. So when I'm looking for y is to 13, as the larger side, 10, is to 26. Cross multiply, solve, and same for x. The smaller side, x, is to 13, as larger side, 24, is to 26. Cross multiply and solve. Here we're doing that same thing in this particular, and we have to look at this one I've highlighted in yellow to find out what is the number, what is the scale factor that I'm multiplying in order to find all of the sides. So I do that and I find that 18 over 24 gives me 3/4 once I reduce it. You'll be using that to set up to find all of the missing ones. So yeah, I could see x and z have 33, and therefore I'm just doing that once because if we do it again, it'll get the same number. So x is to 33 as 3 is to 4. Cross multiply and solve. So we get 24.75 for both of those. And then in the other one for y, we have y over 48 is equal to 3 over 4. Cross multiply and solve. So we can see we're using the 3/4 because that is the scale factor. Here we're reading here. So this is the largest size in terms of pixels that can be used. Even though the image is larger than that, this is the largest the image can be. So 90 and 120. Here we're looking at a scale building, and that is in a ratio of 1 to 200. 1 inch is equal to 240 feet. So what if the scale building was 1,680 feet? And so we're looking for how many inches that would be. So we cross multiply, we get 7. And here, just like I was talking about earlier, uh, these things are similar by a factor of 3 to 1. What if we change that? So we're just simply changing it and reversing it. So instead of SKZ to HJR, we're reversing that. And when we reverse that, we also reverse the ratio, which would be 1 to 3rd.